We are at line segment. This is the beginning of page 3. So on page 3, we've got line segment at the top. I'll let you go ahead and copy these two down, and then we'll talk about what it says over here. Notice that both a line segment and a ray are a piece of a line, which is why we had to talk about lines first. Segment stops on both ends. It's what is the word finite is the opposite of what word? Y'all know. Infinite. Yeah. So it's not infinite, it's finite. It stops on both ends. Okay? Like finite, the word finish, same root as finite. Okay? So it does stop on both ends. So if I wanted to, I could measure this. I could take out a ruler and measure this. You can't measure a line. It goes on forever. You'd be measuring forever. Okay? So a line segment has a finite length. I can actually figure out how long it is. All right? We still use only 2 letters to name it. And again, we would still use only 2 letters, even if there are other points labeled between there, because remember that between any 2 points, this is an infinite row of points. That's what a line is, and this is between these 2 is just a piece of a line. So there are millions and millions of points there. They're just not labeled. So even if they are labeled, like if I wanted to talk about segment JL, I don't have to mention that K is between there. Okay, I'm just talking about all the points between J and L, including point J and point L. The order of the name does not matter. The thing on the top has no arrowheads. That's one way we could tell the difference between a line and a line segment. There's no arrows on the end of that little mark. So the little mark you put over the letters really matters because it tells us what we're talking about. Okay, if it was line MN, it would look like this. This is segment MN. So that means it stops. Ray MN looks different as well. So this is a piece of a line that does go on forever in one direction, but in the other direction it stops. We call that stopping place, that end point, so to speak, we call it the initial point. Okay, so it's the initial point here is M, and then it starts at M, and it goes in the direction of N and through and beyond N forever. Okay, so it keeps going in the direction of the second letter forever. This is very important, and this is what I'm going to talk about why I wrote this right here. The order does matter, and the direction of the arrow is always to the right. Sometimes people think, oh, if I'm going to name a ray that is pointing to the left, like KJ, it's pointing to the left, then I would make this arrow on the top point to the left. No. The arrow is always pointing to the right because you always write the initial point first, and then it's saying, okay, it's starting here and going in the direction of N. So KJ starts at K and goes in the direction of J. So that's why we put K first, J, and then the arrow goes over J to say this is the way it's going from K. It goes toward J and beyond. So the arrow over a ray does not tell you which way the ray points. It always points to the right. It tells you that it's going over the second letter and beyond there. Okay. The next one after that is actually vertex, I think, but I'm going to skip that and come back to it because it makes a lot more sense to me to talk about what an angle is before we talk about what a vertex is. So on the back of this page, you'll see angle is the second item down. Okay. So an angle is 2 rays with a common, you could say end point, but I'm going to be more specific, a common initial point. Okay, so that point where they start is the same point. So in other words, we have, you could say they're joined by that common initial point if you wanted to. We have a ray BA. So this is ray, and you don't have to write ray. I'm just doing it to be really clear. If you write the name of it correctly with that arrow over the top, that reads ray BA. And this is ray BC. So they both start at B, and then they go toward 2 different points. Those are the sides of my angle. So if you're ever asked, what are the sides of an angle, you name them like you name a ray. So you would name, if it said, what are the 2 sides of this angle? I would say BA with the arrow over the top, BC with the arrow over the top. Okay, now I'll come back to this. We'll come back to that. But to name an angle, there's a couple of different ways you can do it, but we're going to stick right now. We're just going to stick with naming it with 3 letters. Okay, and that common initial point, that's going to be the middle letter. What do we call the common initial point? Starts with a V. The vertex. That's why I skipped vertex. I don't know why they're not next to each other on this note sheet. I'm sorry about that. Okay, so that's the vertex of the angle. That's that common point where they're joined. So when you name it with 3 letters, the vertex always in the middle. The vertex always comes second. So I'm going to name this angle. It's kind of like you start at one of the arrowheads and trace your way to the other. So I start A, and then I trace my way back to the vertex and then out the other side. A, B, C is one way to name this angle. The other way would be C, B, A would be another way to name this angle. So A, B, C or C, B, A doesn't matter as long as you put the vertex, that initial point, which is B, that has to come second. Now, the other thing we do when we're naming an angle is we put a little angle symbol in front of it. Sometimes we do it like this. Last period, somebody asked me, what does that mean? Or it might have been the period before that. Because sometimes that looks like an L, especially like if you're not careful. It could look like an L or it could look like a less than. So another way we do it sometimes, and I'll try to remember to do this, is we put a little arc across it. So this just means angle ABC. And we could also name it angle CBA. But notice, either way, the vertex has to come second. And we'll talk about later how you could also potentially call this angle B. But the thing about that is there are specific times that you can use one letter and a lot of times when you can't use just one letter to name an angle. Using 3 letters is always safe. It's always your safest bet. So let's try and be in the habit of using 3 letters. Okay, so now we're going to jump back to vertex because we just talked about it, didn't we? A vertex is the point on an angle where the 2 rays meet. So on that angle we were just looking at, this is the same drawing, B is the vertex. That means when we name it, we name the angle, we name it with the vertex second. So point B, the vertex is a point, and we name it second. To be technical about it, a vertex can be more than just the point on one single angle. Sometimes we talk about a vertex on a triangle or on a polygon, but they are all points where the 2 sides meet. Okay? You could think of them in general almost like corners. All right, I'm going to move on. If you're still writing, you're still going to be able to see it. By the way, if you're watching this as a video later, remember the beauty of videos and why I'll sometimes give them to you is you have control if you want to go back, if you want to look at something again, if you want to hit pause, if you want to fast forward because you've already done this one, that's all on you. So enjoy that control and go for it. So parallel lines. Parallel lines are lines that never intersect. Why was it a shame that the parallel lines had so much in common? Because they'll never meet. I know. Corny geometry joke. But 2 lines that never intersect, they never have any points in common, are parallel lines. Technically, there's another part to it. We usually add the word to coplanar lines, meaning you're drawing them in the same flat surface in the same plane. They're in the same plane. Okay? If you have 2, you can have 2 lines that are not in the same plane, and they won't ever meet, and they're also not parallel. We might talk about that later. Okay? But if they are 2 lines that I can draw on my piece of paper and they're never going to meet, even if I extended them, because lines keep going, they're never going to meet, those are parallel lines. Now, the symbol, I want you to see the symbol of how I write that these 2 lines are parallel. And honestly, since these are drawn as segments, I'm going to draw mine as segments also. Because you could also say two lines or two segments, but so I'm going to say segment HK, which is part of line HK, is parallel to segment PW. So this little symbol in the middle that looks like a tall 11, it's two parallel lines. So this says is parallel to. That's what that means. Okay, next up at the top of the page, back of the page, which is going to be what, page 4? Is that right? Okay, top of the back there, we've got perpendicular lines. Okay, perpendicular lines intersect, but they don't just intersect. They intersect what? What kind of angle? You can see it there on the picture. A 90-degree, a right angle. So exactly, perpendicular lines have to meet at a right angle. Y'all can also see it written there, sorry. No, you can't. Good, y'all couldn't see it. Ha, now you can. Okay, so those two lines meet at a right angle. So I'm going to write it over here so that you can see what the symbol for perpendicular is. I'm going to say segment EP, which is part of a line, is perpendicular to segment UY. Okay, so that little symbol, this looks like an upside down T. That means is perpendicular to. It meets at a right angle. It meets at 90 degrees. In other words, it meets just like a corner in your house. Two walls in your house should be perpendicular for the most part. Sometimes you have angled walls, but most walls in your bedroom or whatever probably have a nice right angle in the corner. So those walls are perpendicular to each other. So again, the upside down T means is perpendicular to. I think we already had angle. One thing, don't draw this. Look at this. I want you to see what I drew another period. One of the reasons it's important to put the vertex second, in the middle, is because if you don't, you're still naming an angle. You're just naming an angle that maybe you don't intend and maybe is not drawn. If I said BAC, this pink angle is what I would be having. So if I accidentally put the letters in the wrong order and I don't put the vertex in the middle, it's still talking about some angle, just not the one I mean. So angle BAC would be that pink one. So that's why the order is very important. Okay, here we go. Straight angle. A straight angle consists of two opposite rays. In other words, we have a ray that is going here and going in that direction, and then this one's going in exactly the opposite direction, and they have a common initial point. So it's two opposite rays. That's the definition of opposite rays. Two rays that have a common end point or initial point and then go in opposite directions. And it makes a line. Two opposite rays or a straight angle makes a line, and it's 180 degrees. Seems weird to call it an angle, doesn't it? It just looks like a line. But sometimes we do. Next up, we have obtuse angle. What does an obtuse angle measure? Is it more than or less than how many degrees? More than how many degrees? 90. Very often we stop there when we say obtuse angle. We just say more than 90. But technically, in this part of geometry, when we're talking about an obtuse angle, we're talking about more than 90, but smaller than a straight angle. We're not talking about more than a straight angle. So we say more than 90, less than 180. One thing to notice here is the little M that I put in front of the angle symbol. That reads the measure of angle STU. So since I'm talking about how many degrees it is, I call it the measure. So the measure of angle STU is bigger than 90 and smaller than 180. That's obtuse. What do you think is next after obtuse? Acute. We know what an acute angle is. It's what? Less than. Where is it? Oh, I don't have it written here. Acute angle. So an acute angle measures less than 90 degrees. Less than, and in case you forgot, less than is this symbol right here, 90 degrees. Okay, so the measure of angle VWX, or I could call it XWV, is less than 90 degrees. That's an acute angle. You could think of it as, oh, it's so cute. It's little bitty, like a cute little kid. We already know a right angle. We've already talked about it. It measures 90 degrees. Okay, I'm going to pause here. There are two ways that I can write that this angle measures 90, and you notice that little symbol also tells me that. So I can say the measure of angle PQR, or I could say RQP, as long as Q is in the middle, equals 90 degrees. Or I could, let's see. I could point out that these two are perpendicular. That's another way of telling you that this is a 90-degree angle. I could also say that PQ, well, let's go ahead and call it a ray. QP is perpendicular to QR. Usually we're going to use this. Okay. Supplementary angles. Supplementary angles. Here is one example. This does not mean it's always these measures, but the two measurements of the angle add up to 180. I'm kind of picky about this. Don't just say the angles add up to 180, because angles are things. Things don't add up to numbers. Like if I put two desks together, I don't get a number. But their measures do. Okay, two angles whose measures add up to or have a sum of, you could say have a sum of 180 degrees together. So it could be 135 and 45 like this. Those add up to 180. It could be 110 and 70. It could be 90 and 90. It could be, and another thing about supplementary angles, they don't even have to be attached like this. These are attached, but I could have, let's say I have an angle that's 50 and an angle that's 130. Okay, so they don't have to be attached like this. That's something else we're going to talk about as well. But these two angles, even though they're not attached, they're still supplementary. It just is about their measurements. And same with complementary. Okay, complementary is just about the measurements. So two angles whose measures have a sum of, and I'm writing it differently just so we remember that have a sum of and add up to mean the same thing, have a sum of 90 degrees. So look, just like these two, they don't touch. They don't have to touch. They just have to be two different angles, and the numbers that describe how big they are add up to 90. 40 plus 50 is 90. They could be 60 and 30. They could be 57 and 33. They could be 88 degrees and 2 degrees. Any pair of numbers that add up to 90 could be the measures of two complementary angles. Keeping this straight sometimes is a problem for people. I like to look at the starting letter here and think about the number and think about the fact that in the alphabet, C comes before S, and when we're counting, 90 comes before 180. So complementary goes with 90, supplementary goes with 180. Okay? Okay, I want to skip to adjacent angles next. Okay? This is an example of a pair of adjacent angles. One way I think about these, or I like to talk about these, is think about the word adjacent. Adjacent means next to. So if I'm in one classroom and another person's in the classroom next door, we're in adjacent classrooms. Now think about those two adjacent classrooms. What do they have in common? Well, the wall between them. They have a common wall in between them. And that's the same scenario happening right here. For two angles to be adjacent, or what we say next to each other here, they share a vertex. They have the same vertex. Okay. and they have a common side, and that common side has to be between them, not, I'll show you what not, between them. Like two classrooms that have a common wall in between them, okay? A way that they could have a common side that is not what I mean, let's look at some letters here. Let's say I have A, B, C, D. Okay, look at angle ABD. That's the big angle, ABD. And then look at angle CBD. CBD is right here. Those are not adjacent because yes, they have a common side. Yes, BD is in both of them. The common side needs to be between them, okay? So not on one side of them. Like one of the angles can't be inside the other. They are next to each other. They don't overlap at all, and they have a common side between them. Notice the names. I could call this one, let's see, ABC and DBC. Notice that if they have a common side, that means two of the letters are going to be the same, BC, BC. They don't have to be in that order, but two of the letters are going to be the same no matter how you name them because they have that common side. Now, a linear pair, let's see if I can do this. I can't do what I was going to try to do, which is show you adjacent angles and supplementary angles that we just talked about on the back of the page. We talked about supplementary angles add up to 180, right? Notice that this pair, remember I said they don't have to be like this, meaning they don't have to be adjacent. A linear pair does. If you have a pair of angles that is adjacent and supplementary, that's a linear pair. A pair of sorry, I didn't leave much space there. I'm going to say angles like that. A pair of angles which are adjacent. I'm doing a bad job of writing suddenly. Adjacent and also supplementary. That's why I wanted to talk about adjacent angles first, because this is where the two come together. They're adjacent angles and supplementary. So they have the same vertex. They have that common side between them. This is one side of A, and it's also one side of B, and it's between them. Another thing to notice is they have not only a common side, but then the sides that are not common, meaning this side of A and this side of B, they make a line. That's why it's called a linear pair. So you have a straight line and one ray coming off on one side. That's always going to give you a linear pair. So these two are always going to add up to 180. All right, we got two to go. Angle bisectors, or excuse me, bisector, singular. An angle bisector is a ray, and honestly, it could be, and I'm running out of ink in that pen, so I'm going to switch colors in the middle of a definition. Who knew? Or straight object. It could be a segment. It could be a line. It doesn't have to be a ray. Usually it's drawn as a ray, but not always. It could be a line. Anything that's straight, anything that's a piece of a line. A ray or other straight object which divides an angle into two smaller congruent angles. Remember, we talked about the word congruent means they have equal measurement. So we're saying two smaller angles that are both equal to each other. They both have the same size. So a bisector, don't get confused with sector. The word intersect, sometimes people get confused with bisect. Bisect means specifically bi is two. So not only does it divide it into two parts, but they're two congruent parts. When something is bisected, it's divided into two congruent halves, basically, two congruent parts. So in this angle, it's like you originally had the angle AOB. That's the big angle here, AOB. And then along comes PO, which is an angle bisector. And PO or OP comes right down through the middle of AOB so that it's giving you an equal size over here and over here. These little markings, when you have matching markings, that says these things are congruent. So that's saying this angle and this angle are the same. So let's say, for instance, what if angle AOB to begin with, let's say it was 80 degrees. The whole big one, if it was 80 degrees, and I'm going to write that. I'm going to say the measure of angle AOB is 80 degrees. I'm making this up. You can't tell that from the picture. But let's just pretend that AOB is 80 degrees. It actually looks a little smaller than that, doesn't it? Then each side would be 40 degrees. 1/2, equal halves. So that's what bisect does. It divides something into two equal smaller pieces. And finally, vertical angles. Vertical angles are angles that are kind of diagonally across from each other at an intersection. So we have an intersection of two lines. When two lines intersect, it always makes something that looks sort of like an X. It could be different sizes. It doesn't have to be exactly like that. It could be an X that looks like this. It could be something like this. It could be really, really narrow. But when you have two lines intersect, it makes sort of like an X, and you have to have that sort of X shape for vertical angles. And then the vertical angles are the ones diagonally across from each other, like these two are vertical angles. And these two, I'm going to do a little 2 here and 2 here are vertical angles. So 2 angles diagonally opposite at an intersection. The special thing about them is they will always be congruent. They're always the same size, always congruent. And one way to say congruent is to use the congruent symbol. Let me show you what that looks like. This is the congruent symbol. So they are always congruent. That's why this says 40 and this says 40. Notice that, remember, angles next to each other that make a straight line. Notice how you have a straight line right there. And then a common side between these two. Those are a linear pair. So linear pairs, remember, are always supplementary. So these two angles have to add up to 180. So 180 minus 40, this is 140. And the same thing down here you could do. So this is also 140. So vertical angles are always going to be the same. And that is it. Okay, this is a little bit longer than I intended, but hopefully you did not need all of it. I think most classes were pretty far into this, but remember, with a video, you can always fast forward, go back, hit pause while you write, whatever you need to do. Thanks for watching, and I will see you tomorrow. Maybe, if you're not just watching it as a video, sorry.